Caney Fork originates quite a bit east and south of here, and it, of course, is dammed at Rock Island and then is again dammed here at Center Hill. It originally was a smallmouth fishery, but of course when they came in and did the dam with the water coming into the Caney Fork, coming from below the thermocline, it therefore is a cold water fishery now. And so it has become a trout fishery rather than a smallmouth fishery.
Well, this is the water quality sensor. Goes off the back of the boat.
So the kayaks are part of our high definition stream survey setup. We can put this setup on kayaks, on canoes, on regular boats, but we also have it on backpacks so that we can do very small streams to rivers like this, all the way up to large things. And the point is that we need to be able to collect a wide range of data that we know exactly where we are and when we're there. That's the GPS side of it. Then we need video because we want to see what the conditions were like, and we need depth and we need water quality and a whole bunch of other factors. All of that's integrated into a logging unit, so a small microcomputer in the center that logs all the information every second from all of our sensors.
Well, I was made aware of the HDSS survey, the high definition stream survey techniques, a couple years ago in a fisheries meeting. And since then I've talked to the gentleman that came up with that process and that survey technique several times, and we've tried to work it into TWRA's sampling scheme and how we would use that on rivers and streams.
This is for the underwater video camera?
So ultimately this will have side scan sonar, GPS, multiple video cameras, water quality, and all of that's linked together, and everything will be logged in this box in the back of the kayak. So when you actually see us working today, it looks just like we're kayaking like everybody else here on the river. We turn on the equipment, it logs every second, and we're able to map both banks, the bottom, the water quality, the height of the water, the depth.
This is essentially the equivalent of aerial photography for the terrestrial side of wildlife management. We've never had something like that for rivers and streams.
The whole point of this is we're going to be covering, I'm pretty sure it's 28 miles of Caney Fork. We're going to cover this in 2 days. Every meter, we're getting information every second from video, from side scan sonar, from water quality, from depth, 4 different GPS units, 4 different video cameras.
So this kind of opens up a lot of the things we can do in rivers and streams. In the past, all we've had is a topo map or an aerial image that shows the surface of the water. It doesn't show anything underneath the water. It's essentially the street maps. A lot of people use Google Maps for navigation and a lot of things. It's street maps for rivers and streams. This technique allows us to get what's underneath the water, what's in the water, as far as water quality, dissolved oxygen, pH. All this can be collected real time and then tied to a GPS point. So we can essentially collect thousands of points down the river and be able to look at those and compare them because the time period is very similar.
The basic idea behind mapping the river and Trout Unlimited, the Cumberland chapter in specific, is that it will give us an idea about what is evolving in this river, how the habitat is changing, areas of the river itself that need work. Perhaps there's bank erosion, or perhaps there's silt coming in from a feeder stream, or any number of things.
Where we're really interested in the HDSS survey on the Caney Fork is over time what happens to the fish habitat and the bank stability. We're going through a period at Center Hill Dam where they're doing construction on the dam to stop leakage at the dam. Then they're going to refurbish the generators. So they may be able to change their flow patterns there. And what we're interested in doing is capturing a base level. This is the Caney Fork in July of 2016, and we'll have that data if we want to go back and look at the Caney Fork in July of 17 or 18 or 19 or even 2020. We'll be able to compare back to that baseline, and that would be river-wide from the dam to the confluence. This allows us to look at fish habitat all the way down the river. We can look at the riparian zone or the sides of the river, see what state those are in. Are they in good condition? Are they highly eroded? We can even tie it to our fish sampling. We can put a camera and a GPS on our sampling boats because we have similar GPS points all the way down the river instead of just localized spots where we we sample or where we have access to sample, like in years past. Trout Unlimited chapter in Tennessee has been a long-standing partner with TWRA on several different projects, but they picked up the majority of the cost of this project, and they look to benefit from this project in ways they can see the river as a whole from the dam to the confluence and pick out areas where they can do restoration projects or habitat enhancement projects. It'll also provide some mapping of fish habitat, so they know where the best areas to wade or the best areas to fish from a drift boat may be. It'll allow us to do some flow models that will explain how much of the river is available to wading at low flows or how much is available to floating at one generator. There's a lot of different things that we can get out of this. We will have the data to make the maps for wadable areas, best fishing areas, and then also we'll be able to narrow down the 10 best spots to do restoration projects or the 10 best spots that we need to protect on the river. So it allows us to look at the whole river all at one time and make better management decisions.